Hey everyone, and welcome to today's lesson about graphing function rules. The objective of today's lesson is to be able to create graphs from equations or real-world situations. Our new vocabulary is continuous graph and discrete graph. Let's go ahead and get started with the lesson. The set of all solutions of an equation forms its graph. Sometimes the graph may include some solutions that don't appear in a table. That's because when we connect those points, it includes all solutions within the points, far too many than we can list in a table. Sometimes a real-world graph should show only solutions that make sense in that situation, and that's what's called a discrete graph. So let's look at a couple pictures. On the left I have a continuous graph, and a continuous graph is a graph that is unbroken. It is a solid line. A discrete graph is just distinct isolated points, and discrete graphs often represent real-world situations where I'm not allowed to have partial quantities. Alright, looking down at a couple of our examples, in order to graph function rules we are going to use tables, and then we are going to plot our points. So in example 1 we are graphing a function. We should recognize what this function looks like. It's a line. But we're going to go ahead and start off by making a table just to get into a good habit. So I'll make a t-chart, x and y, and when I'm graphing I want to pick 5 magical points, and those magical points are -2, -1, 0, 1, and 2. These points are so special because they're all pretty easy to work with. I've got some negatives, I've got some positives, and I've got 0. It'll tell me how the graph is acting at all these different points. In order to come up with the y values, I'm going to plug in the x value and see what I get for y. So when I plug in -2 for x, I see it's -2 times -2 plus 1. That equals 5. When I plug in -1, it's y equals -2 times -1 plus 1. And that's 3. And so on. I plug in 0 and I get 1. I plug in 1, it's -2 plus 1, that's -1. If I plug in 2, that's -4 plus 1, that's -3. Now I move over to the graph. I plot my points. So I go over -2, boom, boom, up 5. I go over -1, up 3. Over 0, up 1. Over 1, -1, and over 2, -3. And I should see all of my points forming a nice solid line. And I'll go ahead and just put in a nice solid line through there. Oop, I whiffed. Let's try it again. Good enough. Alright, now let's take this same logic and apply it to a graph of something we might not know what it looks like. We're going to graph the function y equals the absolute value of x plus 4. If you've forgotten, the absolute value makes numbers positive. So when I plug something in, it's going to be a positive x no matter what. Alright, let's go ahead and fill out our table. I'll use those magical points, -2, -1, 0, 1, and 2. If I plug in -2, that's going to be y equals the absolute value of -2 plus 4, which is really y equals 2 plus 4, and that's 6. If I plug in -1, it's y equals the absolute value of -1 plus 4, which is really y equals 1 plus 4, and that's 5. And I can follow on along. If I plug in 0, that's 0 plus 4, and that's 4. If I plug in 1, it's 1 plus 4, and that's 5. And if I plug in 2, it's 2 plus 4, which is 6. Now unfortunately, this graph over here doesn't fit this set of points very nicely, but we'll make do. I have to go over -2 up 6, that's going to be off the graph. I go over -1 up 5, that's also off the graph. I go over 0 up 4, and that's right on the tip there. Over 1 up 5. Over 2 up 6. The graph of the absolute value makes a nice V. All right, let's turn the page. We'll look at one more example, or a couple more examples before you get to try. We are going to graph y equals x squared plus 1. First going to fill in my table, then I'll plot the points to make the graph. So I'm going to use those 5 magical points: -2, -1, 0, 1, and 2. If I plug in -2, y equals -2 squared plus 1. -2 squared is 4, plus 1 is 5. I'm left with the ordered pair -2, 5. Plug in -1 now. Y equals -1 squared plus 1, and that equals 2. So I have the ordered pair -1, 2. If I plug in 0, we know that 0 squared is 0, and then plus 1 equals 1. So that's the ordered pair 0, 1. If I plug in 1, we're going to see something cool happen. 1 squared plus 1 equals 2. So I end up mirroring what was happening on the negative side. So I get the ordered pair 1, 2. Again, if I plug in 2, I'm going to get the same thing that I did if it was -2, because when I square a number, it becomes positive. So 2 squared plus 1 is 5. So I get the ordered pair 2, 5. Now I'll move over to my graph, and I'll plot those points. I'll go over -2, up 5, over -1, up 2, over 0, up 1, over 1, up 2, and over 2, up 5. And I see that these points lie on the same place on both sides of the y-axis. And this graph makes a nice U-shaped, nice smooth U. All right, last example before you get to try. We're going to determine whether graphs should be continuous or discrete. Looking at the situation, we'll determine whether it should be a set of points or one continuous line. So the amount of gas, G, remaining in the tank of a gas grill depends on the amount of time, T, the gas grill has been used. So, is the amount of gas continuous or discrete? Since I can have partial amounts of gas left in the tank, this is a continuous graph. How about the next one? The number of bagels, B, remaining in a dozen depends on the number, S, that have been sold. Since I can't have partial bagels, this is a discrete graph. All right, now it's your turn. I want you to try the self-quiz and then check your answers. All right, question number 1. You should have graphed a line, and I'm going to use our shortcut here because we know how to do that. The y-intercept is -3, and the slope is 1/2, so you should be going up 1 over 2, and then putting in your line like so. In question number 2, it says Pencil Planet sells a box of purple pencils for $7.50. The cost is a function of the number of boxes bought. So the function is the cost is $7.50 per pencil. So my slope is $7.50. If I buy 0 pencils, my cost will be 0. If I buy 1 pencil, the cost will be up at $7.50. If I buy 2, it'll be up at $15. Okay, this graph is going to be discrete because I can't buy partial, and I'm also not going to have any negative values because I can't buy negative pencils. So your graph should just be a set of points. There you have it. Hope you learned a lot. Let's come to class ready to work.